All right, so in Module 9, you study about polar bonds and nonpolar bonds, and then polar molecules and nonpolar molecules. Today we're going to do a lab that builds on the idea of polarity. So let's have a look at that. Before you come to the lab, I want you to I want you to open the YouTube video that I have a link here. This is a Flynn video that describes how to use a separatory funnel, and that'll help you when we go about it. I'm going to show you how we use our setup here, but watch that video as well. So in this lab, we're going to use water's polar character, to extract ethanol from E85 gasoline. Now, E85 gasoline is not regular gasoline. E85 gasoline is gasoline that has 85% ethanol in it and 15% gasoline. And the interesting thing about that is that the ethanol portion of that gas mixture actually will dissolve in water, while the gasoline portion, the other 15%, will not. Ethanol is only one of a small number of compounds that could be soluble in both nonpolar and polar solvents. If you look at the formula, it doesn't tell you much about it. One of the reasons why we study geometry in this module is because that if you see the geometry of this molecule, you can get some clue about its character. Let's have a look at the geometry of the molecule. So like the formula said, ethanol has 2 carbons in it, and they are located at the center of the molecule. It's got a bunch of hydrogens associated with it, and it's also got an oxygen associated with it. So on this end of the molecule here, you could say that you have a polar bond between that carbon and the hydrogen, but the fact that all of those hydrogens plus this carbon, which is almost the same electronegativity as hydrogen, are going to create a nonpolar end or half to this molecule. But over here on this side, you have this oxygen and hydrogen bond here. Oxygen is one of our most electronegative elements. It's going to pull electrons from both hydrogen and carbon, and it's going to form a polar end of the molecule. And what that makes it is it allows this molecule to dissolve in both polar and nonpolar solvents. So that is the ethanol molecule that we see. All right, let's have a look at this lab now. So just words of safety. When you're dealing with gasoline, E85, or any other kind of gasoline in the lab, that's a flammable substance. You need to wear safety glasses and gloves, and we don't want to monkey around with it. So we're gonna be wise in the way we handle this flammable substance. This is our procedure. We're going to take 20 mils of the E85 gasoline. We are going to add that to our separatory funnel, and then we're going to gently add another 10 milliliters of water to the funnel. Gasoline is less dense than water. That means it's going to stay up on the top of the surface of the water, and it's also nonpolar, so it's not going to mix with the water. So most of the gasoline will remain on the top of the water if you add it gently. The only reason I'm encouraging you to do the gentle adding is because I want you to see that the 2 layers separate out. After you've added them, though, we're going to go ahead and do the extraction. You're going to seal the separatory funnel. You're going to invert it, allow the gas to be released by opening the stopcock with the thing pointed away from your face. And then you're going to invert and shake gently and relieve the pressure until no more gas pressure is generated. At that point, we have created an emulsion, probably more of an emulsion than we really want, but that will allow the extraction to proceed. The next thing to do is we're going to set the flask down, and we're going to leave it for about 10 to 15 minutes, and then let the 2 layers separate out. After they separate out, there shouldn't be much volume in the top layer anymore. Most of that ethanol will have moved into the lower water layer. And once that happens, we're going to pull off that lower water layer by draining it out the bottom of the flask and record its volume. And when we do that, we're going to do our best not to get any of the gas layer in that. And I'll show you what that looks like in a second. And then we're going to then drain off the upper layer. And so you should at that point have 2 different graduated cylinders, one with a water layer with ethanol in it, and one with much smaller volume now with the gasoline. And then we will verify to test that you do actually have ethanol in the water layer. And to do that, we will ignite just a couple of drops of that water layer. And as long as there is greater than 40% ethanol in it, it should ignite. All right, let me show you how the procedure looks. Our extraction setup. I have a 60 milliliter separatory funnel. Whenever we put this thing together and before we add any fluid to it, we'll make sure that the stopcock is in that position so that the fluid doesn't run out the bottom as soon as we do. We have a cap that goes on the top of it. So the first thing that we're going to do is we are going to add our 20 milliliters of our E85 gasoline to that. And I'll just show you a quick look at the difference between regular gasoline. You see how yellow that is compared to the E85. It's got a yellow hint, but it's far more pale. And that's because the E85 is 85% ethanol, which is clear, but it's also got 15% of the regular gasoline in it. So I have a 25 mil volumetric pipette here. I'm just going to pull it up to 20 mils and then add that 20 mils to our separatory funnel. And to get it up to 20, bring it up to the, it says 5 mils there, and add it into the flask. All right, and I'll put the cap back on my bottle so if I accidentally knock it over, I don't spill it all over the place. And now I'm going to add 10 milliliters of water to it. And just for the sake of seeing the two layers separate, when I add my 10 milliliters of water, I'm going to go ahead and take my pit and lower it all the way to the bottom of my separatory funnel. Let's see if I can give you a better picture of that. There you go. That way, the water layer, which is going to be more dense, it will stay at the bottom, and we should see two layers form, a water layer on the bottom, and then all of that ethanol should be pushed up. Let's see if that happens here. The water I'm using is just tap water. There's nothing, it will work fine for the extraction. So 10 milliliters now of our water. And like I said, I'm going to put it in the very bottom. I'm trying not to disturb it. I know the whole point is to do an extraction, and it makes sense. That is going to disturb it, but let's see what happens here. If I can keep my two layers separate. That ethanol is really going to want to move into the water layer. So if I'm very rough with it, it will quickly leave the gasoline layer and move into the water layer. All right, just about got all my water in there. Pull that out. All right, so you can see that there are now two layers here. This lower layer has got our water in it. Let's see if it's a better picture if I get it closer to you. Yeah. There we go. Now you can see it really easily. That's our water layer there, and that's our gasoline layer. What's going to happen, the ethanol that's in this gasoline layer here, it's going to really want to be in that water layer. And so when we invert and shake this, that top layer is going to move from being, a large volume to being almost no volume whatsoever. It'll just be just a tiny bit. And that's because most of what's up here is ethanol. It's not gasoline. You can see right here in the middle, we're getting this emulsification kind of a layer. Unfortunately, once we do our extraction, the whole water layer will look kind of cloudy like that. But we'll see if we can get that to clear up. So now for our extraction. What we do to pull that off is we put our stopper, there we go, on our separatory funnel. And then we put our hand on top of the stopper and we invert it so that we do a little bit of mixture, and then we close the stopcock, and we're going to invert it again a few times, allow the gas to escape. There we go. I don't hear any more gas coming out of it. And now we have two layers once again, but shockingly or dramatically, this top layer right here, let's see if I can get it to you. This top layer right there is the only gasoline layer that's left. This section that's all cloudy, that is now a water layer. It does have some gasoline in it. You know, if you were to smell this, and you know, whenever we take it out, you'll still smell the aroma of gas. But mostly all that gasoline is still there, but the 85% that was the ethanol is now in this layer. And the cool thing is that whereas before that layer was just water and clearly not flammable, but now we have moved a lot of ethanol in there. And as long as we have more than 40% ethanol in that layer, we'll be able to ignite it. So we're going to take about 15 minutes and allow this to sit and see if we can get the cloudiness to dissipate. We'll see if it will clear up. And after that time, then we'll pull off the water layer and separate it and in its own graduated cylinder, and then we'll collect just the gasoline layer. So we'll stop for 15 and come back to it. All right, well, it's been about 15 minutes to let set, and unfortunately, the cloudiness hasn't cleared up a whole lot. I don't think that's going to change our result a great deal. But I can show you that if you look in the gasoline layer, it's just crystal clear, just gasoline up there. You know, no cloudiness in that top little layer. But obviously, as you move down in that water layer, it's cloudy. And part of that's because the ethanol has brought some of the gasoline with it into the water layer, but you can see none of the water is up there. There's no cloudiness at all in that upper layer. And I don't have any perfectly clear layer down here. A lot of times if you just let it sit long enough, all of this will clear up and it will look just like water again and clear, but we're going to kind of run out of time before we accomplish that. So we're going to go ahead and proceed with our lab. All right, I'm going to put this back in there, and then we are going to pull off the water layer, obviously first, because it's the lower layer, and then we'll pull off the upper layer. In order to do that, I'm going to put a graduated cylinder. Now remember that we started with only 10 milliliters in the water layer. But now, because a lot of that ethanol has moved to it, we're going to look and see the volume. This is a 25 mil graduated cylinder. We'll just look and see what volume is in the water layer. And then after that's said and done, we'll collect the gasoline layer in the 10 mil graduated cylinder and see what the volume of that is. All right, so I'm going to reorient this and then we'll pull that off. To make room for my graduated cylinder, I'm going to lift up my funnel. So put my graduated cylinder under there to collect the fluid. Lower it back down a little bit instead. At this point, the part that we're going to watch really closely is this gasoline layer up here. We will watch it get closer and closer to the bottom, but what we don't want is we don't want to collect any of that gasoline in into the graduated cylinder. So we will stop the flow before we do that. All right, so now we're just, first thing I got to do in order to get it to drain very well, I got to take my stopper off. I'm just going to allow the water layer to come off the bottom. As I do, you can see that it kind of looks like the gasoline layer gets a little more volume, but it's actually just moving to a smaller part of the flask. You can see it a little easier. And we're going to keep an eye on that. And as it gets close, we're going to slow down so that we don't collect any of that gasoline layer if we can avoid it. That a little better. Controlling it as I go. There we go. Now I have a little tiny bit of an emulsion right there on the top of the stopcock, but this is all the gasoline layer. And this is now water layer. And I only have a 25 mil flask, but you can see that I started out with only 10 mils in the water layer, and all this volume is ethanol that's come from my gasoline layer. So what I now know is that the vast majority of the volume here is ethanol. It's not water. And if I only have to have 40% ethanol to ignite, then clearly that should ignite. All right, so I'm going to set that off to the side. Emulsification layer on there as well, but it will stay at the bottom. And we'll collect this gasoline layer now. Just let it completely drain out. There. And our gasoline layer started with 20 mils, and look at that. It's got 2 mils left. That is it. Now, granted, some of that gasoline, it is in here because if this was just all ethanol, it wouldn't be cloudy. So there's a little bit of gasoline in there in emulsification. But we have gone from a 20 mils to a 2 milliliter volume of that gasoline layer. All right, now I'll show you what it looks like to test it. So to test it, we're just going to put a couple of drops of our gasoline in one of those wells and look at it. When we did our previous lab on incomplete combustion, when we tested gasoline, we noticed that it kind of had a sooty flame because of incomplete combustion. So I'm going to go ahead and take a couple of drops of that out of here. Go ahead and just put it in the well. Turn it to my. And I'll keep that pipette with my gasoline mixture. And if I ignite that flame, and it will ignite, but it's kind of hard to see on your. See if I can shield it enough. But, unfortunately, my camera doesn't pick it up, but that was a nice yellow flame. And she's all gone. When you do the lab, you'll be able to see it better. And then I'll take some of the ethanol mixture once again and put it in here. A couple of drops of that. And ignite that flame. When I ignite it this time, I'll try to shield it so that it doesn't seem so shiny, but it's impossible to see. Well, she's finally burning really well, but I don't even visually, I don't see any flame at all, but my hands around that, I feel it. So there's no doubt about whether there's a flame there. So that's how we're going to do an extraction, and then how we're going to verify the components of the extraction. And after that, the only thing left to do is to clean up your mess. So I will leave you to do the lab now.